Hey guys, welcome back to Math from my desk. So today we're going to deviate a little from math and go into chemistry. So there's still some math involved, but it is after all a chemistry problem. So the problem is from Khan Academy, and the problem states the following. The molar mass of gallium, big G, little a, as represented in the periodic table, is 69.72 grams per mole. Calculate the number of atoms in a 27.2 milligram sample of gallium. The answer should be in scientific notation and with three significant figures. So as stated before, the problem is from Khan Academy. So first of all, first of all, we know that the sample here is in milligrams. So we're gonna go ahead and convert that to grams, because as we can see here, the molar mass is in grams per mole. So first thing first is we convert the 27.2 milligrams of gallium into grams. So we're gonna go ahead and write that down. 27.2 milligrams gallium. Well, for every gram of gallium, there's going to be 1,000 milligrams of gallium. And so 27.2 divided by 1,000 is 0.0272. And we notice that the milligrams for gallium cancel out. So we're left with grams for gallium. All right, now that we have done our conversion, we're gonna go ahead and calculate for the number of moles. And then from the number of moles, we'll be able to calculate the number of atoms using Avogadro's number. So let's go ahead and convert this, to moles. So we're gonna calculate the amount of moles. So first of all, we're gonna write down the measurement of the sample of gallium. So it is 272 grams of gallium. And so as you might know already, we're supposed to divide by the molar mass. So the molar mass is already given to us. It's 69.72 grams per mole. You can also find the molar mass in the periodic table. This is where this comes from. Okay, so we know that for every mole of gallium, there's going to be 69.72 grams of gallium, as defined here, 69.72 grams per mole. So we just put that out here. So we're gonna go ahead and divide this. So divide the 0.0272 grams of gallium by the 69.72 grams per mole of gallium. So let's go ahead and do this. And so here, this is what we get. And so remember, guys, in a problem, when you're in the middle, in the middle of a problem, it's best not to round to any significant figures, so that you have a more accurate outcome. You can round the outcome, but usually not inside the problem. However, since I already have the full number here in my calculator, I'm just gonna go ahead and round this here in my paper so that it's easier for me to write. So let's just round it to 3.9. This is in three significant figures, but our answer is going to be in three significant figures. Sorry. So the grams of gallium cancel out. And so we're left with moles of gallium times 3.9 times 10 to the -4th. So the E is just a times 10. Moles of gallium. And so now we're able to calculate for the number of atoms. So what the question asked us for, and we know that based on Avogadro's constant. So Avogadro's constant, Na, is 6.022 times 10 to the 23rd. So this is Avogadro's constant by the famous chemist Avogadro. So you multiply the number of moles by this constant, and you should be able, well, by definition, you get the number of atoms. So let's go ahead and do just that. So we're going to write down the number of moles first. 3.9 times 10 to the -4th moles. per gallium. All right, well, times here the atoms is 6.022 times 10 to the 23rd atoms of gallium over 1 mole of gallium. And so the moles for gallium are gonna go ahead and cancel themselves out. So we just multiply this number. So again, this is the full number. Do not round in the middle of a problem. So I already have that in my calculator. Times, so we time this by the Avogadro's constant, also called Avogadro's number, times 10 to the 23rd. And so this is our final answer. So we're told to write in 3 significant figures and in scientific notation. So we're going to go ahead and do just that. So this number in significant figures is 2.35. And in scientific notation, times 10 to 20, to the power of 20. And so the number of atoms is as follows. So this is the amount of atoms in 27.2 milligram sample of gallium. I hope you guys enjoyed this video, and I'll see you soon.